let's start with a very simple but a very cool example. And you'll see why it's cool very soon. Okay, we're going to describe the motion of an object whose coordinates at time t are given by the system of equation x equals cosine t and y equals sine t. Okay, and you might be thinking, oh my God, I have no idea what that goes like. I have no idea what that is. How do I do this? Do not panic. Okay, this is actually just an illusion. This is a very simple graph once you learn how to do it. Okay, so if you don't know how this graph goes, why not make a table? Okay, that would be the easiest way to find out how this graph goes. Okay, so we can have t. So since it goes with respect to t, and x and y all along here. And since this is a trigonometric functions, we're going to go by increments of 1/6 pi. Okay, so 1/6 pi, 1/3 pi, and then we're only going to go up to half pi. That's like 90 degrees. Okay, so we're only going to do that, and we'll find a pattern. So I don't want to have to make you guys go through everything of trigonometric functions. But you guys should know this. Cosine t equals, cosine 0 equals 1. Sine 0 equals 0, right? And sine, so this is a 30-degree angle. Remember the triangle that goes like this, and 1, 2, root 3, right? So this is 1/2. This is 1/2. This is root 3 over 2 and root 3 over 2. You guys should all know this from pre-calculus. I shouldn't have to explain myself, right? And this would equal 0 here and 1 here, right? Okay, let's now try graphing this. Okay, x-axis, y-axis. So let's say we got a point 1, 0. Let's say this is 1 here. So we got a point here, 1, 0. And the last point is 0, 1, right? The last point here. So let's say this is 1 here. So that would be the last point. And in between, we got this and that. And it's actually going to look something like this and this. This one being the, this one. And this one being this one. It's actually going to look like that. And if we connect it, it's actually going to look something like this. And the pattern here, if I tell you, I'll just tell you. It's a quarter circle, right? It's a quarter circle because it's a sine function, and it's going to be drawing actually a full circle if we go on, and draw a full circle on and on because it's a periodic function that goes on forever. Okay, we can actually do this algebraically, which is actually a lot easier because if we notice this, we can actually square both sides. So x squared equals cosine squared t, and y squared equals sine squared t. And we know that we know the identity cosine squared t plus sine squared t equals 1, right? And we can now substitute it with x and y here, right? Substituted, and it becomes x squared plus y squared equals 1. Okay, which is an equation for a unit circle, and but that's not the important point. We're trying to understand right now. We're trying to understand the basic intuition behind the parametric equation, and the way we are going to do it is, this is a cool part. We're going to look at some cool graph making process. Okay, so we're going to look how this graph graphs itself out. Okay, so we do know that it's going to draw a unit circle, but how is it going to go? Okay, I'm going to explain the process bit by bit. Okay, so let's look at some graphs. So this is x equal cosine t part. We know how that graph goes. Okay, and according to time t, it's going to move along the line. Okay, move along the line, but only the value of the t. The value of this function is for the x-axis. So it's going to be moving up and down between 1 and -1. Okay? So only that matters, between 1 and -1. And it's an x-axis, so we turn it around. For the y-axis, it's similar. Okay? We know how the sine graph goes. Okay? It goes up and down, travels along according to time t. But again, it travels between the value -1 and 1. Okay? So only that matters. Okay? And we're practically taking the t part out of the equation. And this is the y-axis. The upper one is the x-axis. We combine it. And it's going to start, we're going to see its movements now. Okay? See its movements. It's moving very, very slowly. And if we connect the coordinates, it draws a circle. Okay? We're connecting the coordinates together. Remember I told you the coordinates are, coordinates would be cosine t, comma, sine t, right? We're connecting the coordinates together, and this is what we get, okay? A unit circle, according to, x squared plus y squared equals 1. Okay, isn't that cool? I think it's pretty cool, okay? I rather enjoyed it. I hope you did too. Okay, next on, now that we understand, hopefully, the intuition behind the parametric equations, parametric functions, we're going to move on to some examples.